Okay, we discussed this is GR450. I brought it in from Florida. I originally noticed that it did not start, so what I did is took a look. The connector had obviously been changed, and that was most likely the problem. But I re-terminated it, did a re-termination, and powered it up, and it didn't work. It had a 10-hour trip in the back of my truck. I got it here, and first thing is to duplicate the problem, and it didn't work. So I went back and took a look at the connections, and one of these was loose that I re-terminated. I don't understand why it was loose, but I'm going to tighten it back up right now. If you look, we have a green connection. That is green. Neutral is the shiny. The hot brass portion is the brass. You need to look that up online. Also, if you want to know where the schematics are, I found them online doing a search. And if you look here, it was under Mike's Tools. I just did a Google search. And there's the GR490 8-inch grinder. And that was the part I wanted to get right there. Alright, if you take a look, you'll see there on the right the power plug, the switch, the PCB, a light, a motor, and the connections. For my own reason, I printed out this so I could work and mark things off as I troubleshoot. So you know, it's January of 2025. If you look outside, I'm in actually the kitchen where the table sits, not on the counter, and I'm in here because it's miserably cold. So anyway, it's a bad weather front. So let me tighten this down. Hopefully you're seeing this. Okay, there we go. Now it's digging in. Okay. Alright, so let's check all these connections again. I'm going to re-terminate it most likely with a better connector. But I want to see if we can duplicate the problem. That's step one. Okay, that's in. This is in. But I'm not going to run off to the store. This is duplicating the problem, step one. And when I re-terminated it, I noticed it was not right originally, so I cut back a lot of the insulation, understanding that I was going to troubleshoot it and go back in. There goes one. There's two. There's three. And you can also see I got a TV there. It's on mute. Because frankly, it's all the same after a while. They're talking about investing, and these people tend to want to invest in gold. Some people want crypto, some people want other stuff. All right, let me set this up for a quick check. Alright, I'm currently plugged in. I can see the light on the end of the extension cord, and you shouldn't use an extension cord, I'm certain, and read the manual. However, this is just temporary. Let's turn it on. Nothing. Off. On. Nothing. This is the safety switch. So, with that, we've duplicated the problem. Let me see if I can get it to spin. Alright, when I checked it out originally, okay, I have to get a light bulb. When I checked it out originally, it did the same thing. So let's take a look at how this unit is. And step one is to unplug it to make it safe. It's now unplugged. Alright, there's the parts breakdown. I'm sorry if the glare's too large. But we have the power plug, it comes in to the rear. We got the motor assembly there. We have the circuit card PCB right there, a plate on the bottom, which you'll see shortly, a switch that we need to check out, and 85 is the capacitor. And I kind of guess that way it's either, well, we'll see. We got to troubleshoot it. Those are the parts. And I'm going to zoom in so we can take a look at what we're going to do next here. We checked the plug right here. We should have a green, a white, and a black wire. We have 1, 2, 3, 4, 5, 6 wire nuts. And I'm going to start right here. And I think originally when I troubleshot it, I made did my troubleshooting, I made sure that we had power on the PCB, and it appeared to have worked. But we're going to go back over the switch and everything else. I was told the light doesn't work, so we'll see about that as well. We could have a loose wire nut or connection here, a blown PCB. Well, we'll take a look. First thing is to always guess something physical. All right, that's kind of the way I see it. And then with capacitors, that's also kind of a second guess, but number one, we're going to go through it all correctly and patiently. All right, we're still unplugged, so I'm going to move that over here. Let's just see how bad these Phillips screws are. You can see it. Screws are somewhat rusty, and they're not coming out. So we'll deal with that here in a second. I'm going to remove all this hardware here so it's out of the way. This spins backwards. Basically, you'd be spinning on to get it to come off. So here's one piece here. On this side, there's a problem with the threading on this guy right here. And I'll address that later. Okay. That's this side. And I'm going to remove the 3 screws here. Light bulb first so we don't break anything. Yeah, That's my sister, all right. Okay. Arrgh. Okay, here we go. Man, oh man. All right. I'm gonna go work this real quick. Okay, this is my KAIFNT, Kavent. I got this because I needed, I'll put a link if I remember, to remove some big Phillips, like a number 4. This is Phillips 1, Phillips 2, and here's the tool to help remove the screws, plus a 3/8 drive to 16th. This is a very good set. That's why I chose it, and it stays in the box. Here we go. And the way this works is you hold it steady, you hit it with a hammer, and it rotates the screw ever so slightly. Let's see if I can do this here. Here we go. And there you see it coming out. I hope you see it coming out. And we're going to go on to the next one. Hold it. Okay, and then we're going to go to the next one. Hold it in place. Okay. And I don't know how good that worked for you guys watching it, but there it is. It broke the 3 screws loose. So let me get the 3 screws out. I love it. This is natural. Everything's always a battle. But I'm not out in the cold and miserable, so I'm good about all this. I don't want to do that. There we go. Back into the screwdriver, trying to be about as gentle as I can be. All right, very good. All right, let's see these 2 front screws. They're also Phillips number 2s. I hope we're catching this. I'm sorry if we're not. That one spun free. This one's not quite there. There's always one in the group. Alright, I'm going to have to rotate this up on end and work on it a little more. I'm going to do this off video. It was filled in with some crud, rust. I tried to make sure I could get on this the way I got on the other one. You can see this is a Phillips and a flat blade. And indeed, what I had to do is change up my Phillips number 2 with a standard flathead, stand it up on its side, and indeed, you take a look, I loosen the screw. So we're going to get the screws out. Remember, we're unplugged, be safe. One. Two. There's the cover. We take a look. We got a rheostat with 3 wires going somewhere. Let me, wow, take a look on in there. Let's see if we can do that. And then I'm going to straighten up. Stand by 1. All right. What I want to do is to check this switch out first. Before I pull the contacts or leads, what I want to do is see if we have continuity from the motor to the switch. If you look up there, you'll see we have through a wire nut continuity to one of the blades on the plug. Alright, you should be able to hear it. We do have continuity. And then I'm going to turn the switch on. And we have continuity through the switch. Let's set it on resistance. Two ohms. $13 ohms. If I turn off the switch, we are open, and we are still shorted to the line. So that appears to be good. Let me just take a look at neutral real quick. Nothing. And then let me also take a look at ground and come to a ground, and we can see the ground is good. So that's basically saying the switch is good. So that's kind of what I saw when I did the testing originally, and I'll show you that here in a minute. Alright, I bought this years ago. I forget where, I think it was eBay. But brand new. This is a fluke meter, the greatest as far as I'm concerned in the world. But I don't know, I was trained with them. So anyway, any meter will actually work for you. The important thing are the test leads. Okay, I'm going to flip this up on the end and take off the base plate. You'll see here 4 connections to hold that base plate on, and that wasn't there. So I don't know where those are, where they were lost. I see 2 of them here that are tied directly to the iron bottom of the unit. So let me get these off. 1 in a washer. 2 in a washer. Let me set these so I have a clue of where they are as I watch someone who I can't hear talking something, how to get rich or something like that. Nice people, I'm certain. Okay. All right, let me get the light going here. Right, if you let me get the camera the right way, hold on a second. All right, now that I'm not in a rush like I was in Florida and had to get out of there, I was end of my vacation. We have, if you look, wires going up to the motor, and it looks like there's two blacks and two reds. That matches the schematics. We have the capacitor right there. We have the plug that comes in right there. We have a wire, a black and a white, that go to the light right there, and that matches up with the schematic. We have the PCB assembly. What I don't see is this resistor assembly up here. This is a resistor with control wires. These are control wires that go up into the motor up in there, which are obviously controller, and I'm certain that we will see this is all part of the PCB assembly, which is why it isn't there. We see a blue-black wire. That's this one here, the blue-black, which goes to the black that goes to the motor, a black that goes to a white that goes up there. But we don't have schematics on this, and we also can't see exactly what that capacitor is. 2004, I'm speculating, is a year. We're gonna get to that. And here is the back part right here of the switch assembly. Here's the switch. Okay. All right. We got two screws that appear to hold on the PCB assembly. So let's remove that. Next. Seems like we have some insulative material. There is the PCB assembly. We got potentiometers there. One says max, one says minimum. Right there, if you look, never have enough hands. That says min, that says max, and they're glued into place. So that's the setting on the for the variable speed, which most likely, and this is just speculation here, that comes in from the speed control. We have some resistors, and we have a chip which has been, I think, ground off, so I can't tell what chip type it actually is. Right here we got a sensor connector. I hope I'm getting this. A sensor connector here. Wire. These are high wattage, 5 watt, 10K, 5 watt, 10. Oh, maybe it's kilojoules. Maybe I don't know what size those are. But what really bugs me, and it doesn't bug me, but it does, is we have a dip chip right here. 1, 2, 3, 4, 5, 6, 7. And with those 7 pieces, connectors on each side, it's a 14-pin dip. And if you take a look, and this is fascinating, I've done this in the past myself. In order so I don't know what that chip is, all right, they have ground off the top of the dip chip so you can't see what part that actually is. But we'll take a look at that. And then we have another part here that we'll have to take a look at, and this is most likely a voltage regulator. We have a capacitor. I think these are tantalum capacitors here, and electrolytics that are there. So I'm going to have to go one step farther and think. I'm going to actually have to think a minute on how I want to kind of troubleshoot this. But step one, I'm going to remove the connectors and card and take a look at it, see if we have any identifying features. Alright, in disconnecting these wires, the first one goes to the card and up to the switch, to the bottom portion of the switch. Right, the next one is a black with a white streak and white that goes down to the card. What I think I've decided to do is, before I cut wires, remove connectors, I want to remove this circuit card and take a good close look at it with you. So here's one screw. It's loose and loosening up. Here's another screw. Now mind you, this is unplugged. Everything is safe. One, two. Alright, so there you saw the circuit card move. So the circuit card is free. Right here, I'm pushing it forward so we can see what the card is. It's just a simple 2-layer card. Doesn't have multiple layers on it. We see a mistake on the R10 where they have 2 resistors tied together to change the resistance in the system, and I cannot see what this chip is. But it's old enough that I'm guessing it's not programmable. That could be a big mistake on my end, because they do make, microchip makes programmable chips that are that size. But I'm guessing for this application it isn't. But that's just a wild guess. right? You can see on the card this number here. It's a YL 2003-0420. Flipping the card over, all right, you see an FZ108 right there by my finger. FZ108. And that's as far as I'm gonna go for now. Actually, I'm gonna take a look at this capacitor. That's what I'm gonna do next, this capacitor. Alright, there's one screw that holds that in place. It's a CBB60SH, 60 microfarad plus or minus 5%, 50 to 60 hertz, 250 volts AC, minus 25/85 degrees centigrade, NINGBO Halidia. And I'll have to take a look at that. Plus there's something else here. 2004.11. Alright, so it's time for me to go do some lookup and finish part 1 of this video, and hopefully it's successful.